Hey Royals, so today's lesson, what we're going to talk about is motion diagrams. So motion diagrams are kind of like that freeze frame photo that you see of, say, a ball flying through the air, that you see it here and then here, then here, then here, and it gives you an idea of how fast an object's moving. Now there's one on our unit outline sheet, and it shows us this motorcyclist jumping through the air. There's also one on the in-class portion of a baseball pitcher throwing the ball. Now, the baseball pitcher one's not the greatest because you don't actually see the object moving out of his hand. So what I mean by that is you don't actually see the ball flying through the air. Okay? So imagine I had a ball here, and I close my eyes, and I open up my eyes, and it's here now. That's two different positions. And if I know the time it went from here to here, and then maybe the same amount of time it went from here, from this location to this location, I would be able to determine how fast it's moving. So how far it moves in 1 second or in that period of time tells me how fast it's moving. Now this is exactly what motion diagrams tell us. So if you had this gentleman here, or woman, or this royal here, moving, I could consider their position at this time, right? And I've just put down a ball here to represent that position. Now they may have moved, say, in 1 second to this location, and I would say that their change in distance would be measured between the distance of the two balls. So this would tell me, say, 1 meter. And then this next piece may be 1 meter. And then the next piece might be 1 meter. And I noticed that the spacing between these is all the same. And so let's assume that the delta time in each of these was 1 second. And you would be able to determine the speed of this person just because it's like speed is how far they move, distance, divided by their time. So if I take the distance between any of these, let's say that this is my speed, and we're going to use a v to indicate that. And it will make sense when we start talking about speed and velocity, why I'm using a v. So I'll call it v1, and I'll call this one v2. I can say that the distance that this person traveled in 1 second was 1 meter divided by 1 second. So I can say 1 divided by 1 is 1, and I can find out that they are moving at 1 meter a second. Right? So that tells us really quickly that if this distance was larger, this could be like 1 kilometer, this could be 1 kilometer, and this could be 1 kilometer. The distance between these dots just simply gives us an idea of how the object's moving. Now in class, what we're going to do is I'm going to give you a meter stick. I'm going to give you some toy cars, and you're going to measure how far they go in a certain period of time. And we're going to make our own motion diagrams. So basically you're going to draw a dot for every position that the object is at every second. Okay, so if I was thinking about something that was speeding up, so imagine I have my car, and I'm not a great artist, but I'll try my best. There's my car, and let's say that it is originally at 0. And I'm going to start drawing dots, and you'll be able to tell very quickly that this object is speeding up. And I know that because the distance between these 2 points is smaller than the distance between these 2 points, and it represents the same amount of time. And obviously, if these 2 points, the distance between them is larger in the same amount of time, the object must be speeding up. All right, so if you have any questions, don't hesitate to reach out to me.